In this video, we're going to talk about derivatives not in terms of x, or perhaps the derivative is in terms of x. It depends. So every time that we state a rate of change, we state that rate of change with respect to something. For instance, if we talk about speed, we're talking about distance with respect to time. When we discuss slope on a Cartesian plane, we use the formula m equals y2 minus y1 over x2 minus x1. In other words, we talk about the change in y with respect to x. Similarly, when we determine a derivative, which is just an instantaneous rate of change or slope at a point, we determine the derivative with respect to something. Usually we determine a derivative with respect to x. However, this isn't always the case, or doesn't necessarily have to be. So let's do a question where we do determine a derivative with respect to x. This part here on the bottom, that's saying with respect to x. So this is like saying the change in y with respect to x in an instantaneous way. So to do this, this is a derivative the way we're getting used to doing it. Just multiply 4 times 3, we get 12. Times 2x squared plus x minus 1, quantity to the 3, times the derivative with respect to x of what's inside, which is 4x plus 1. And that's the end. That's the end of the question. That's the answer. So that's something you're used to, but perhaps you're not used to this. Notice in the last question, I said the derivative of y with respect to x. Now I'm saying the derivative of y with respect to 2x squared plus x minus 1. Well, it helps some people at this point to give a variable to 2x squared plus x minus 1. So I'll use the variable w. I'll say let w equal 2x squared plus x minus 1. Well, if I do that, then clearly y is 3w to the 4. Okay, so now I'm going to determine the derivative of y with respect to w. Now, we know that if y is 3x to the 4, then dy over dx would be 12x cubed. So similarly, if y is 3w to the 4, then the derivative of y with respect to w will simply be 12w to the 3. So in other words, a simple way of thinking of this is we're doing the power rule on 3w to the 4. We're getting 12w cubed. We're determining the derivative with respect to w. We have w here as the base of the exponent. There's no need to do a further chain rule. We're done. But since the question was asked in terms of 2x squared plus x minus 1, what we'll do now is we'll replace the w here with 2x squared plus x minus 1, and we'll replace the w here with 2x squared plus x minus 1, and that's the answer. So literally the answer that the question is asking us, the answer to that question is this. Okay. Now, what if I ask you this question here? What I'm saying there is what's the derivative of 4 times 2x squared plus 8x plus 3 quantity with respect to x? Well, the derivative of that would simply be, we apply the power rule and or the product rule to that right there. And we get 4 times 4x plus 8. And that's the end of the question. Okay. Now, just to reiterate something we learned in one of our earlier lessons, if you're not quite sure why the derivative of this quantity here with respect to x is merely 4 times 4x plus 8, then think of it as a product rule where the first function is 4 and the second function is 2x squared plus 8x plus 3. if you think of it that way, and if you think of y as being 4 times 2x squared plus 8x plus 3, then we can say that the derivative will be the derivative of the first function, which is 0, times the second function, which is 2x squared plus 8x plus 3, plus the first function, which is 4, times the derivative of the second function, which will be 4x plus 8. And so simplifying that all together would give you 4 times 4x plus 8. Okay? Next question here. What if you're asked this question right here? Well, one way to think of this is to say let y equal 3x squared minus 2x plus 2 quantity cubed, and then let w be 3x squared minus 2x plus 2. If we do that, then y is equal to w cubed. That would be w cubed if I let w equal this. And I would be looking for dy over dw. 3x squared minus 2x plus 2 quantity cubed is y. 3x squared minus 2x plus 2 is w, so I'm looking for dy over dw, where y is w cubed. So I can simply do a power rule on w cubed, and I get 3w squared. And no need for a further chain rule because the base of the exponent is the that which I'm taking the derivative in terms of, so I'm fine in that regard. And at this point, I can sub back in for y, where y is equal to this quantity right here, 3x squared minus 2x plus 2 quantity cubed. And with respect to w, where w is this quantity right here, 3x squared minus 2x plus 2. And the answer is 3w squared, but again, subbing this quantity in for w, that expression in for w, we get this expression, 3. Okay, so the derivative of the derivative of w cubed with respect to w is 3w squared. If you can do all of that without introducing the new variable of w, which some people can do just by looking at it, they see, okay, I understand what you're saying, sir, but I don't need to do the substitution step, then don't do it. You don't have to if you don't have to. And finally, we get this expression right here. Well, by now, you might be getting used to the idea that we like to get this written in terms of this. Okay. So keeping that in mind, I'm going to see if I can simplify the expression 2x squared plus 12x plus 18. Well, that's equal to 2 times x squared plus 6x plus 9. And that's equal to 2 times x plus 3 quantity squared. So what I'm going to do is I'm going to let y equal 2 times x plus 3 quantity squared. And I'm going to let w equal x plus 3. If I do that, then that means y is 2w squared. And then it means that this expression here is really the same as dy over dw. Now, if I've got y written in terms of w, then dy over dw is a really simple task. It's just a simple chain rule. Or sorry, a simple power rule. I get 4w. And now I'm done. Now I go back, and as I've said before, you want to get your expression back in terms of x. So again, we know that y here is 2 bracket x plus 3 quantity squared, or in other words, 2x squared plus 12x plus 18. And we know that this w right there is the same as x plus 3. So dw is dx plus 3. And the answer is 4w, or in other words, 4 times x plus 3. And there is what we were asked, and we've now answered the question asked of us. And once again, I say, once you get used to the thinking behind this, you might not need to introduce a new variable to do this. You might be able to do it just by observation. And if that's the case, by all means, do it. Okay?